Silencio, Bruno.
Sí.
Sí, cuando quieran.
Adelante.
Sí. Good night. First of all, I want to thank Ocean Blue Tree, Montse e pela Ryoka com Ra. Vou tentar. Maurício e James por a invitação, for invitation, for the invitation. Mixed up English and Spanish. And I'm presenting one topic a bit different from the ones you're presenting because we are doing MPA, but it's also an important subject because a lot of us spend a lot of time in the fieldwork and have a lot of opportunities to develop researches with the side observations that we make during our fieldwork. So we, as I said, spend a lot of times underwater. We have a lot of records of different behavior observations, fish species, different colors, different behaviors, as I say. And then this is also one opportunity to study other research fields than our main research fields. So we have opportunity to learn more about ecological interactions and other subjects, and also to make more collaboration because some of these other research fields are not our main research fields or research interest. And then it is open more space for collaboration with other groups. And I'm gonna talk about some specific species that we were working and collecting data, and had the opportunity to develop new studies, new questions, and had very interesting observations from these works. The first of all was in 2019 or 18. In 2018, we were tagging the Mobula trapacana, the Chilean devil rays. And then we saw a feeding event where 13 Mobula rays, that Chilean devil rays were preying in this bait ball, and then in a bait ball, and then we were able to see also the mantas preying, but also the remoras. So we had a lot of records of the remora with snipe fish on the mouth for the whale shark and the manta rays as well. And then we are able to describe this feeding pivot behavior, where the ray swim below the bait ball, and then move like more fast through the ball, and then attack the ball and swim below. And one ray make this attack at a time. Like they swim around the bait ball, and then each one at a time go and make this behavior. And then we asked from Stewart and these collaborators for a video that they had in Costa Rica with the same feeding behavior, and then we analyzed it, and then realized that they made the same behavior, like they swim a bit below the bait ball, over the bait ball, and attack the bait ball. So it was a really nice opportunity to describe behavior from a side project. And then also for the devil rays, we were studying the development of the tags with the hydrodynamic models. And then during our field work, one more time, we were thinking, what is the drag that the hemeras do for the whale sharks? How many hemeras for the devil rays? How many hemeras each devil ray carries, or how the size comparable, and how is the overall drag? And then we start to make hydrodynamics model to study the hitchhiker's drag. And then now we have this paper under review about the abundance, distribution, and the hydrodynamics of the remoras on the devil rays. Then we assessed the sites on the devil rays, the areas where the hemeras are more frequently attached, and with the hydrodynamic models, we calculated the drag of each remora in the manta is more or less 4%, and it's not uh, additional because they are not is additional because they are not online, and so each remora adds 4%, more or less 4% of drag. And there's more images, but I'm not show here because we got to read the paper to see more details. I just show these two ones. But one interesting thing is that most of people thought that the megafauna, the fishes and whales, dive deep to evict the parasites. But these diving ray swim down in a power dive of almost 5 meters per second from the surface to 400 meters in 1 minute and a half, and the remora still attached on its body. So the deep dive or fast dive is not a reason to get rid of the parasite. And then we analyzed for these papers the dives below 400 meters. But then when we saw this behavior, we thought, oh, let's see all the videos and see what if they do the same for whale sharks, and let's see all the videos for the diving rays. And then we realized that the remoras and pilotfish could go to 1,500 meters. So it's very impressive. These two small fishes that can go to this depth. So they are super fishes. And then again, we had a new question, and then let's study these fishes to analyze or to understand how or why they support such extreme conditions. And then we use some heart rate sensors with internal temperature, as George said, and then we deploy some in some animals, and we made a drop in this ship to see how the deep diving behavior, how the behavior of the deep diving in relation of the heart rate and the internal temperature. And then we send them to 1,500 meters a couple of times to understand, and we had very interesting data. And now we are waiting for the biochemistry analysis to understand more about the biochemical changes in its body. So it's another interesting research that we started after this observation. So we also made some erythermy, ergometry, and respirometry with pilot fishes and remoras to understand their physiology. And then this is all study that's under development. We are now starting this new area. This is new for us, so we also made collaborations to do that with researchers from Japan, from Iceland, and Portugal mainland, because they are more expert on that area as physiology. So we had the animals and the opportunity, the possibility to collect this data, but we need collaboration to move forward because we cannot do everything by us or our group. And then for the blue sharks, the same. We start to study blue sharks for the high resolution behavioral, like energy expenditure, spatial analysis, and movement ecology. And then we had this particular shark, the scarface, was sighted first time in 2017, and until 2023 we kept returning to the Azores. So we thought this, as the blue sharks are oceanic sharks, they don't have phallopatry. So we could see that some sharks at least can go back to the same place over and over the years. So we also had this other shark that we tagged with a cow tag, just to interact with the diving operators to see how much long this shark stays in the area. And then we have the surprise that this shark, after 1 year, came back to the Azores. So it's like another shark that came back after a while. So it's a really interesting data that we had from opportunistic research. And also we now, after that, are thinking, is that possible to photo ID blue sharks using the dorsal fin images? And now we try to start this study to see if we can assess this. And then one surprise also, last year we had a report from one of the sharks we tagged, was captured by the Spanish fleet 2.5 months after we tagged it. And then I get this like in, I guess, beginning of the last year, so it was 2.5 months after the shark was tagged. We also have this mortality data using this basic science, basic method. And also during a collaboration with other group that were tagging blue sharks, we start to catching short fin mako. And then we say, oh, we have our tags here, why not tag the mako shark to analyze the swimming behavior, the energetic cost of swimming. And then we tag this shark, 3 sharks, and then we had the first insights of the swimming behavior of the makos. So we could estimate the swimming speed in relation of the tail beats and also the recovery time after tagging. So basic information that we have from 3 sharks that is very useful for other taggings that we're gonna do with this species and other species. So this is only some graphics, some information of the paper. And then also, again, for the whale sharks, the whale shark that George told in his presentation start to occur in the Azores in 2008, 7, 8. And then the first study that they made was about the occurrence in their fringe habitat. So they observed that there's a isotherm of 22 degrees, that when it's warm enough as 22 degrees, the whale sharks are capable or is more optimal to get close to the island. And then after 2013, as George said, the whale shark disappeared from the island. Nobody knows why. But with the same data set, George and other researchers in the Azores also analyzed the whale shark interaction with the tuna fleet, the tuna fishing fleet. Then they realized that the diversity of the fishery to catch the tuna and the amount of tuna that they catch were related to the occurrence of whale sharks. So again, the first signal that the whale shark and the tuna associate for some reason. And then the whale shark start to show up again in the Azores in 2019. And then we start to study the movement patterns, spatial ecology. And we after some years, we start to see more closely the relationship of the whale sharks and tunas. So we realized that they hunt together. And we don't know yet who depends more upon who, because the whale sharks sometimes are preying, like attacking the bait ball, and the tunas are with them. But sometimes the whale shark dive and there's a bait ball and the tuna dive with the whale shark instead of keep eating. So who is helping who or who needs who, we don't know yet. We are trying to understand this using the accelerometers and the video footage to qualify and quantify the association with the tunas and analyze the feeding behavior of the whale shark. So this is a new question because in our first question was to analyze the energy costs of swimming of whale shark and also the feeding and energy cost of feeding. But now we have a new question from, again, the observations. And then also with this opportunity that we have to collect data, we also are preparing, finishing a study with the population dynamics of whale sharks in the area. So we use photo identification, photogrammetry, and with citizen science, we were able to identify 254 whale sharks. It's a very impressive number because we rely upon the citizen science because basically our team to do that is me and George. So we have a lot of friends, diving operators doing this, helping us to get the whale sharks. And our estimate is for more or less 600 whale sharks around the island. So we also had the opportunity to see how many whale sharks had scars and the degree of scars. So we also have some information about the boat striking with the whale sharks. And also through thinking about how many times these animals spend in the surface. And we have the colleagues in the University of the Azores also that study microplastic around the seamounts and hotspots of megafauna. We came up with the idea to study the surfacing behavior of the whale sharks, the devil rays, to estimate the plastic injection in this area. So one more time, one idea that came after we start the work and with collaboration. So we, as George said, collaboration is in our DNA. And this was just random records of different fishes with different colorations. So we had some from collaborations. This great hammerhead from French Polynesia from a colleague diver, and other records of albino, leucistic, melanistic, and we also had the first melanistic giant manta in the Azores. Like it's the northernmost record of this variation. So it's very important to be aware of what's happening to get information. And then just one, while I was preparing the presentation yesterday, I thought, oh, everybody's talking about nurseries and how important the nurseries are for the sharks, for the hammerhead sharks particularly. And in the Azores, we just described the first temperate oceanic nursery for the smooth hammerhead sharks. And it's also probably a nursery also for the taupe sharks. So we are still studying for the taupe sharks, but we have a lot of good data for the hammerhead to prove. So we use the Hupel 2007 criteria, and then we have these three criteria that prove that is a nursery. We use fishing, acoustic telemetry for 4.2 years, and satellite telemetry almost 500 days. And then we saw that despite the hammerhead sharks swim around all the islands, they concentrate more in this receiver in the north shore of Fayal. So we can see here, all the big circles are September. This is the summer months. Then they are, and we use also satellite telemetry. We combine two because we thought if the acoustic telemetry doesn't get the habitat use all the movement, so let's put some satellite text to see more the home range abroad the island. Then even with spot tags, they stay close to the shore, close to the north shore. And then other colleague was doing his master, and then he used isotope, stable isotopes to analyze the niche partitioning and these two species. So this is a area for the nursery area for the hammerhead, but also for the taupe sharks, and they are dividing this area and in different autogenetic age. So there's juveniles and subadults and adults, but they are using the same area. So it's a nursery area, but also essential habitat for feeding for the two species. And now we just finished also another work with more data, now using BRUV in fisheries to assess the hotspot areas for the taupe sharks and hammerheads also. So we have these areas north shore mainly for the hammerheads and east side for the taupe sharks, and we are doing the same for the whole archipelago. So this is only for the Fayal Island, our island now, but we have the same information using also the local ecological knowledge for the whole area and more data to try to show if there is more nursery area in the Azores. And this is one BRUV videos of the smooth hammerhead that we have over there. Yeah, that's it. Thank you.